We will discuss about some problem based upon the capacitance and inductance. So the example number 7.3 of NCERT. Let's see here, a lamp is connected in series with the capacitor. All right. Now the end structure diagram is like this. A lamp is connected in series with the capacitor. So here is a capacitor and a lamp is connected across this capacitor like this. Alright, so this is a capacitor and this is a lamp L. Alright, and what happens in each case to the DC and AC connections. So in case of AC combination, when input is in the form of alternating voltage, so now this is the same capacitor and this is the same bulb is connected across it. Okay, so the question is asked from you, a lamp is connected in series with the capacitor. So this is the same capacitor and this is the lamp. Okay, now here input voltage is in the DC form and here the input voltage is in the AC form. This is AC component and this is DC component. So predict your observation DC and AC connections and what happens in each case if the capacitance of the capacitor is reduced. So as we know that in the figure number 1, this is figure number 1 and this is figure number 2. So you know that in case of DC supply, capacitive reactance is equal to 1 upon omega c, which further written as 1 upon 2 pi nu c. So now for DC supply, for DC nu, this frequency is equal to 0 because it's a direct current. So using this, this part will become 1 xc will become 1 by 0, that is equal to infinite. What does this mean? This means that for the DC current, this capacitor will show the infinite capacitive reactance to the circuit. So no, the lamp will not glow. And to the second case, if the capacitance is reduced, no change will take place. Okay, and in case of figure 2, for figure number 2, here your input is in the form of AC voltage, and in case of AC, the capacitive reactance is equal to 1 by omega c, which is further equal to 1 upon 2 pi nu c. Here this frequency is some finite value, is of some finite value, and xc will become finite then. So as we have discussed it earlier, that if AC will flow through the capacitor, but capacitor will too, it limit the current, it limit and regulate the current, and capacitor allow the AC to pass through it. So capacitor allow AC to pass through it. Okay, hence the lamp will glow. So another part of the question is, if the capacitance of the capacitor is reduced, what will happen? If capacitance of the capacitor will reduce, then if the capacitance will reduce, what will happen? Xc will increase, and if Xc will increase, if C prime is I mean मैं यूँ ऐसे यूँ लिखते हैं. Okay. So in this case, if we'll reduce the capacitance, it will increase the reactance. If this part will be reduced, if C is reduced, what will happen? XC will increase. Okay, capacitive reactance will increase, and the lamp will shine less brightly, and the lamp will shine less brightly. Okay, so now we'll go for the another problem, that is 7.4. So this part of the problem is example number 7.4, a 15.0 microfarad capacitor. So capacitance of the capacitor is 15.0 microfarad. This is 15.0 cross 10 to the power minus 6 farad. Okay, and it is connected to the voltage 220 volt, and frequency is 50 hertz. Alright, so find the capacitive reactance. You have to find XC, that is equal to 1 upon omega C. This is what you have to determine. And current, current में आपने क्या निकालना है? I, that is also equal to I root mean square value of current. एक ये निकालना है, और एक peak value of current, ये वाला part निकालना है in the circuit. So if the frequency is doubled, so if जो न्यू प्राइम है आप उसको डबल कर दे, what happens to the capacitive reactance, then तो आपको क्या निकालना है? XC प्राइम भी निकालना है, and current, and I root mean square value of current. This is what you have to determine. So now to start with, capacitive reactance, solution of this problem is the capacitive reactance is first thing that is asked from you. The capacitive reactance XC is equal to 1 upon omega C. This means it is 1 upon 2 pi nu C. So you can write it like this: 1 upon 2 cross 3.14 cross 50 cross C is 15.0 cross 10 to the power minus 6, which is then equal to 212 ohm. You can solve it. You are 10 plus 2 students, so you can do this ordinary mathematics. This is 212 ohm. Now another part of the question is, now this is asked from you, root mean square value of current. So root mean square value of current could be determined like, we know that V is equal to I root mean square value of current, and resistance is capacitive reactance. So I is now root mean square value of current is equal to voltage upon XC. So voltage is given to you. This is 220 volt, and XC you have determined now. This is 212. Okay, so this will come out to be 1.04 ampere. And another thing that is asked from you, maximum value of current. So we have the relation I root mean square value of current is equal to the maximum value of current upon under root 2. So I maximum value of current is equal to under root 2 time I root mean square value of current. This means it is 1.41 time root mean square value of current is 1.04. So this is then equal to 1.47 ampere. So now what will happen, this is the maximum value of current, and how it will fluctuate, as we have discussed that instantaneous value of current I is equal to Im, and if it is across the capacitor, then it is sine of omega t plus pi by 2. So this fluctuation will be like that. So this component, the sine theta, will fluctuate this part between its positive and negative value. So here Im is equal to, if it is 1.47 ampere and this part is minus 1.47 ampere, so this could be shown like this, right? So this is what the variation of current with time. All right, so now the next part, if now the further question is asked, if now frequency is doubled, it is 2 times nu. So if frequency is doubled, then use the relation xc prime is equal to 1 upon 2 pi nu prime. So you can put it like this, and this is 2 pi time 2 nu into c. So this is equal to xc by 2. This means that capacitive reactance will reduce to half, and if it is reduced to half, then current is doubled. So current is doubled. Okay, so this is all about this problem. Now we'll shift our discussions to another problem that is given to you. It's very interesting. Example number 7.5. So in example number 7.5, a light bulb, this light bulb, and an open coil conductor, this part, are connected to an AC source, see here, through a key, this part, as shown in figure 7.11. अब हम क्या करेंगे, ये जो स्विच है इसको क्लोज कर देंगे. This switch is closed. After some time, iron rod is inserted into the interior of the conductor. इस कंडक्टर के इंटीरियर में, देखिए अब इसको हम दोबारा बना देते हैं. ये जो आपका डायग्राम है, so this is an inductor, and this is the bulb, right? And this is alternating voltage, and this is basically the diagram is. So what will happen when you close the switch, and then iron rod is inserted in between, right? Iron rod is inserted in between. सवाल आपसे पूछा है the glow of the bulb, अब बल्ब का जो ग्लो है वो क्या बढ़ जाएगा, या ये घट जाएगा, या ये फिर वैसे का वैसा ही रहेगा. ओके, so as the iron rod is inserted, give your answer with reason. So I will try to explain this. जब आपके पास एक सिंपल इंडक्टर होगा only, then magnetic field across this coil is equal to mu naught time Ni. I hope that you are agree with this. So जब आप स्विच ऑन करते हैं और इसके अंदर एक आयरन की रॉड डाल देते हैं, what will happen then? Its magnetic field will increase. This V prime is equal to mu naught Ni, that is due to the coil, and this is mu 0 time M. This is because of the magnetization of this this rod which is inside it. What will happen? This magnetic field will increase. With increase in magnetic field, magnetic lines of forces will increase, and we know that If the magnetic lines of forces will increase, then phi is equal to Li. This means that inductance of the coil will then increase. If inductance of the coil will increase, what will happen then? Inductive reactance XL, that is equal to L omega, this will increase. This will also increase. And if this inductive reactance will increase, then you know that the voltage drop across the inductor, that is I time XL, will also increase. Voltage drop across the inductor will increase. So voltage drop across the inductor will increase. So from the input, large amount of voltage will be dropped across the inductor, and small amount of voltage will then be available for this bulb. So the glow of the bulb will decrease. The glow of light, glow of light bulb decrease. All right. So this is all about this problem. So now we are left with the variation of current and voltage across the capacitor, as we have done already. So we will start discussing it in the parts, because we have done more part of it in case of inductor also. Now see this in this waveform. So this is in the 4 quarters. So quarter number 1, 0 to 1, and then 1 to 2, 2 to 3, and then 3 to 4. So the charging will take place from 0 to 1. Then discharging will take place now from 1 to 2. Again charging will take place from 2 to 3, and discharging will take place from 3 to 4. So see carefully. We first concentrate from the portion 0 to 1. It's a first quarter. Now see here, this is the current. This is the current. So current start decreasing in this case. It is maximum at 0, minimum at 1. And then this voltage is increasing. Voltage is increasing from 0 to 1. And the voltage follows the charge. Charge is also increasing from 0 to 1. Now see what will happen now. As the power is a voltage cross I, so here both of these voltage and current are positive, so the power is positive. So if power is positive, then energy is absorbed from the source during the first quarter of the cycle. This is what we have to learn from this part. And then here the power is positive. Okay, so in the second quarter, see carefully, this is the discharging part. This is the discharging will then takes place. So well, in the second quarter, now see carefully, the current is now negative. It is increasing in a negative side, and will reach to this minimum value, increasing with the negative slope, and will increase to this up to its minimum. And then the voltage is positive, but current is negative here, and so that the power is Vc into I. So as the current is negative, voltage is positive, so power is negative. Alright, so discharging process will then takes place. From this it is shown in figure also. Basically it is shown in figure like this. So this part of the process is looks like this. This is this is the discharging process. It could be shown like this, and the current will flow like this, right? This current I, and in the first case, the charging process for the diagram will be like this. This is the A part of the capacitor, and this is the source of voltage, and this is the flow of current. This is the charging process. It is shown like this. Okay, so here is the discharging process will then takes place in this form. So rest of the part is what I have explained to you. As the power is negative, so the energy is absorbed during this quarter of the cycle, as from 0 to 1, and is returned during this quarter. The energy absorbed in the first quarter is returned back in the second quarter. So now from the section it is 2 to 3. So this is the once again the charging process will then takes place from 2 to 3. So see carefully, I continues to flow from A to B. So current will flow now from A to B. See this says this arrow, current is flowing from A to B, and the capacitor is charged to reverse the polarity. Now so this is now positive polarity. Earlier it has negative polarity. This is the plate A, this is plate B. Now here in this case plate B has the positive polarity, so the polarity is reversed in this case. That is, the plate B acquire the positive and A acquire the negative charge. So both the current and voltage are negative in this case. Now see here, this is what the voltage is negative and current is also negative. So negative, negative, positive. So power is positive in this case. And if power is positive, what will happen then? So the capacitor absorb the energy during the third quarter, right? So now go back to the fourth, from 3 to 4. So discharging process will then takes place. So here the current reverse the direction. The direction of the current will be reversed and flow from now B to A. So accumulated charge is depleted and the magnitude of the voltage VC is reduced. Now see there, voltage is now going to reduce from a minimum to 0, and now here the current is positive. Now see carefully, this current is positive. So voltage is negative, current is positive. This means power is negative in this case. Now see carefully. So the energy absorbed during the 2 to 3 is now returned to the source, and the net energy absorbed is 0. So this is all about the variation of the voltage, current, charge, as well as the average power. This is the way how these quantities will vary in case of charging and discharging of capacitor. So I have tried my best to explain the concept to you, and if you still have any question, then you can write in the comment box. Thank you so much.